Hi, I'm Bob. The utility is a measure of the consumer's happiness or satisfaction. The utility function is the relationship between the utility measures and every possible bundle of goods. A utility function assigns a numerical value to each bundle of goods. I will introduce some commonly used utility functions today. The indifference curves we have learned in the past two videos have a close relationship with the utility function. All the combinations of goods on an indifference curve have the same utility value, like 4. A higher indifference curve has a higher numerical value of utility, such as 6. But the value number itself has little meaning. The utility values only reflect the consumer's relative ranking of the bundles. The most commonly used utility function is called the Cobb-Douglas Utility function. It has the form U equals Q1 to the power of alpha times Q2 to the power of 1 minus alpha, where U is the numerical value of utility the consumer receives from consuming Q1 and Q2. Suppose alpha is 0.5. Then in our example of noodles and ice cream, the amount of utility that the consumer gets from consuming noodles and ice cream is U equals Q1 to the power 0.5 times Q2 to the power 0.5. In the graph, the indifference curves correspond to the utility function. I1 is for the utility value of 4. It includes any Q1 and Q2 bundles such that Q1 times Q2 equals 16, such as the bundles 4, 4, 2, 8, 8, 2, 1, 16, and 16, 1. A higher indifference curve, I2, represents all the combinations of bundles and ice cream with a utility value of 6. It includes the bundles 6, 6, 4, 9, 9, 4, 1, 36, and 36, 1. For a utility function, we can calculate the marginal utility. Marginal utility, MU, is the additional utility that a consumer gets from consuming one more unit of a good. It can be expressed as partial U divided by partial Q. It is the change in utility with respect to a slight change in the quantity of a good, holding constant the other good. For the Cobb-Douglas utility function, we used the marginal utility of noodles, MU1, equals partial U over partial Q1. Similarly, the marginal utility of ice cream, MU2, equals partial U over partial Q2. It can be proved that the marginal rate of substitution of noodles in terms of ice cream is equal to the marginal utility of noodles divided by the marginal utility of ice cream. For the Cobb-Douglas utility function we used, the marginal rate of substitution equals Q2 over Q1. The utility function for perfect substitutes is a linear function. One example is U equals Q1 plus Q2. The marginal utility of Q1 is 1. The marginal utility of Q2 is also 1, so the marginal rate of substitution is 1. For the perfect complements, the additional utility from one more unit of a good while holding constant the other good is 0 because the two goods must be consumed together. Finally, let me emphasize that the utility function represents the ordinal preference or the preference ranking. In our example, the utility values of 4 and 6 tell us that I2 is preferred to I1, but it doesn't tell us how much I2 is better than I1. In general, given a utility function that is consistent with a consumer's preference ranking, we can transform that utility function into an unlimited number of other utility functions that are also consistent with that preference ranking. The transformation is called the positive monotonic transformation. For instance, the function f that equals x squared is a positive monotonic transformation. The utility function v, which is equal to u squared, represents the same indifference curves, but the numerical values become 16 and 36. Thank you for watching this video and subscribing to my YouTube channel. See you next time.